All right, hello everyone. I'd like to do a special lesson on reverse chain rule. I just feel like not many students like reverse chain rule, or not many students are actually confident using reverse chain rule. And I'd like to show you how everyone can use a reverse chain rule and why the reverse chain rule is so powerful when you're integrating certain expressions. All right, reverse chain rule is the way. Obviously, is the way to do instead of using the substitution method, which is alternative way of reverse chain rule. All right, so we'll start with, a concept. What is a reverse chain rule and how do we use it? Well, speaking of reverse chain rule, it definitely comes from the chain rule. All right, so for example, when you differentiate a function, all right, what is chain rule? All right, when you differentiate a function, so say for example, you've got y equals to f bracket gx. Now, usually when we're talking about chain rule is you have a function inside another function. All right, it's function in a function. You might have multiple functions that's inside another function, and if you want to differentiate, so dy over dx, and then that gives you, if you want to differentiate that function, it will be f dash bracket gx. And then according to the chain rule, you need to differentiate what's inside the function. In that case, it will be g dash x. All right. There's another way on the textbook they usually write reverse chain rule like this. No, sorry, not reverse chain rule, but chain rule like this. dy over dx is equal to dy over du times by du over dx. All right, very, very similar. Same idea. What they are doing here is just replacing the gx by u. So you differentiate a function in terms of u, and after you finish that, u dash, which is just du over dx. All right, that is a chain rule. But what is a reverse chain rule? Well, if you look at that, all right, you need one extra derivatives before you can integrate this entire things back to the original function. All right, so let's just show you the first example. This formula here, y equals to fx to the power of n. How do I differentiate that function? Well, to differentiate that function, we do dy over dx is equal to n, move the power to the front, fx minus the power by 1, and then you multiply by the derivative of the inside function, right? And that will be f dash x. That is the chain rule. And that's how you do chain rule here. Now, what is a reverse chain rule? Well, if I want to integrate this one back to the original function, how do I integrate? With something to the power of n dx. Can I integrate this one straight away? No, you can't, right? What you need to have is the f dash x right in front of it, right? You need to have f dash x. So you need to apply f dash x to the front. All right, then you can apply the formula. All right, so that is a reverse chain rule. You've got f dash x here. Everything is ready. Then you can start to integrate. You plus the power by 1, and you do the reciprocal of the power. Please do not write anything that's under this one here. I just don't like to write something like this. It looks really ugly, all right, and it's not nice at all. I want a coefficient, because it's much easier for you to do the later calculations. If the question asks you to integrate again, it's just much easier. It makes sense. Don't write it in terms of fraction, please. Even majority of textbooks, sometimes they do over n plus 1. It's ugly, all right? That's what reverse chain rule is about. Now, obviously, the reverse chain rule applies to so many different functions, right? And today I'm just going to do the function, the polynomial type of functions, all right? In the future lessons, I'll talk about how do we do reverse chain rule with different functions, like trigonometry functions, exponential function, log functions, or inverse trigonometry functions. All right, so let's start with some examples. Let's start with the first example here. We'll start with something that's really simple to begin with. Integrate 2x plus 1 to the power 4 dx. Okay, now if you want to integrate this, the first thing you need to do is start to think about this. This is my fx, that's n. I need something. Right? I need a term right in front of here so I can integrate, I can use the formula. And what is that term? that will be the derivative of inside bracket. And that derivative of 2x, when you derive 2x, that's 2. So what do I need? I need 2. All right, you need a 2. So what do I do if I need a 2? Well, you add a 2. Put a 2 here. It's just that simple. You put a 2. All right, and then you copy everything down. Now you might ask, no, that's not right. They're not equal to each other. Yeah, they're not equal to each other. So what do? Well, since you add a 2, well actually times by a 2 here, how about we times 1 over 2 outside? Because by doing that, you basically have done nothing, right? Half times by 2, just 1, and that's just 1 there. But the most important thing right now is that's f dash x. Let me just label this one for you. That's f dash x, and this one is fx, and that number here is n. So you have the correct form for the formula. All right, you have f dash x in the front, you have fx in the bracket, you have n on top. That's how you do it. All right, so once you finish that, you can start to integrate. So how do I do it? Well, keep that half outside. That 2 disappeared with the formula. 2x plus 1, all right, plus the power by 1, that becomes 5. Now, have you noticed that I actually left a space here? And this is my habit, all right? I left a space here because I know I need to find the reciprocal of the power, which is 1 over 5, and I'm just going to put it right in the front, n plus c. That looks really nice, and that's how you integrate it. All right, so now 1 over 2 times by 1 over 5 is 1 over 10. Then it becomes 2x plus 1 to the power of 5 plus c. And that's how you integrate it. All right, very simple. And this is the key. All right, you need to differentiate what's inside a bracket, and then you need to make sure you times that number before you integrate. All right, so this is an example 1. All right, I'd like to show you, a few more examples to show how the reverse channel works in different examples. But remember, today's lesson, I'm only going to do reverse channel with polynomials, all right? We're going to do something else later. Example 2. How about I want to integrate something like this? 15x over a square root of 6x squared plus 2 dx. All right. Now, most students, when they see something like this, when they see a question like this, they don't know what to do. All right? They don't know what to do. It's just too much. You've got a fraction, you've got a square root, you've got a square, you've got a number on the top. No, they just give up. All right? They firstly, they don't know which formula they should apply, and then some of them, they might be able to do some, substitution, using substitution method to work out the answers, but it just takes ages to do. All right, so how do we do it? It's pretty simple. If you see fractions, if you see square roots, get rid of them. You don't want fractions, all right? You don't want a square root. Just get rid of them. So integrate 15x, and then that square root actually becomes power of half. And that over, that's a denominator, so it's a fraction. Just put a minus in the front, right? That's all. And make sure you write down dx. That's all you have to do. Because what you get fx here. You get n here. And how about this part? That should look like f dash x. All right, so what do we do now? Remember, I told everyone before, you need to differentiate what's inside the bracket here, because that's, fx. I need f dash x. I need f dash x right in front of these brackets. So when you differentiate that, that's 12x, right? Let's just write 12x here. You need 12x. I have 15x. How do I do it? How do I change 12 to 15? Or 15 to 12? Now, you can times by a fraction if you want, but the easiest way is just move the 15 outside. All right, just please have a look at it here. All right, move the 15 outside. So you leave a space here. All right, and then what do you need? You need 12, right? So put a 12. How do I cancel the 12? Well, you divide it by 12. Just that easy. All right, so that way you have a 12 that you need, and you know the number outside, which is perfect. You've got everything you need. F dash x, fx, power of n. Everything you need, all right, is here. All right, so now let's continue. Do the calculation. You can simplify this one here. Divided by 3, so that becomes 5 over 4. And then you start to integrate. Remember, leave some space here. So you get 6x squared plus 2 plus the power by 1 becomes positive half. Reciprocal of half. And that's why I don't like to do something like over half here. Because look at that. Really ugly, and a student will have a problem with this simplification. Don't do that, okay? Half, find the reciprocal of half. That's 2. Just put the 2 right in the front. Plus C. You've got your answer. And then all you have to do is simply just 5 over 2. Calculate this part here. 6x squared plus 2 to the power of half plus C. And then that's it. So it looks like a really hard question because you've got fraction, you've got square roots and everything. But to be honest, it's not hard. All right. Firstly, you need to realize this is something that you can do with reverse chain rule. And then the next step is you need to remember that I need to find the derivative, what's inside brackets. And that derivative is 12x. And you don't have 12x, that's okay. You move the 15 outside, leave a space so you can put it 12 and you can put a 1 over 12 outside. And all you have to do is follow the rules to work out the answer. It's pretty easy. All right, straightforward. Okay, we're going to move on to another example. All right, now this time it's going to be a tricky example here. All right, tricky example is example 3. So let's integrate. Let's say we are going to integrate something like square root of x to the power 3 plus 6. And we do dx. Now here comes the question. All right. Now, when students first see the question here, all right, I guess you'll probably say, yeah, but you've told us you have to change the square root to the power of half, and that's the way I'll do. And then some student will say, oh, the derivative what's inside the bracket here is 3x squared. So how about I put 3x squared right in the front and try to do 1 over 3x squared. Can we do that? Now, the answer to that is no. All right, this is not right. We can't do it. What's the reason? The reason is really simple. You can't add x squared. You just can't times by an unknown number x and outside you times by 1 over x squared or 1 over x. You can't do it. You can only do this question by multiplying a number, a constant number. All right, like a 3, a 4, 2.5, fraction, decimals, doesn't matter, but it has to be a number. You can't do anything with prenumerals, so you can't add it. All right, and then how do we do this question here? Well, you can't. At this stage, no. If you want to use your reverse chain rule, no. There might be another way you can do the question by using substitution methods, but right now, if you want to use the reverse chain rule, no, you can't do it. So how do we do it then? They have to tell you. All right, they have to give you something x squared outside. So when they provide you the question, they have to tell you this is a 10x squared outside, for example. All right, so once they tell you this is 10x squared outside, then you can do the question. So how about we move the 10 outside? I don't really like the 10. And then we change this question here to the power of half dx. Now you differentiate what's inside, that's 3x squared. And that's the reason why I moved the 10 outside, because I need a space. All right, I need a space. All right, now once you get 3x squared, then that's really easy now. What you can do is I need to add a 3, right? I need a 3, I add it. That becomes 3 here. And then let's do 1 over 3 to cancel that 3. So it's 3x squared, x to the power 3, 6 half dx. All right, now we can integrate. The reason for that is this is f dash x. And here is fx. That is the power, so it follows the reverse chain rule formula. All right, so that gives you 10 over 3. Remember, this part disappeared. X to the power 3 plus 6 plus the half by 1. And that gives you 3 over 2. Now, do I do this over 3 over 2? Well, I hope you know the answer. No. Just tell me what's a reciprocal of 3 over 2. Well, that's 2 over 3. So times by 2 over 3. plus c, you got your answer. All right, so finally you've got 20 over 9 after you time these two together. And then here we go. That becomes the answer of the question here. Don't worry about changing this one back to the fractions, right? You don't back to the square root. You don't need to do it. That is the final answer here. All right, so yeah, it's a short lesson. All right, but I hope after this lesson you understand a bit more about how to use reverse chain rule on a simple question like this. In the future lesson, I will teach you how to do the reverse chain rule with other functions, like trig function, exponential function, with other functions. All right, thank you.